Hello, everyone. My name is Fabio, and I work as Technology Director for intive. Welcome, and thanks for joining us in today's webinar, where we'll be discussing blockchain and smart contract applications for the FinTech domain. Before we start, let me remind you that today's webinar is part of our series on game-changing technologies for FinTech. Previously, we have had 2 webinars on ChatGPT. If you missed one of them, you can get recordings in our YouTube channel, and you can also follow us on LinkedIn. Our speakers today are Rodrigo, who is one of our senior principal software engineers and blockchain expert, and Pablo, who is one of our Scrum Master product owner, who plays an instrumental role in our blockchain chapter. Today, they will drive us through blockchain, smart contracts, and smart contract applications. Last but not least, please ask us any questions you may have on the topics of blockchain and smart contracts. For that, please use the question and answers box at the bottom of your Zoom window. If we don't pick your question during the presentation, we have reserved 15 minutes at the end of our 30-minute presentation just for questions and answers, where we'll do our best to answer all your inquiries. Cheers and enjoy. I will leave you with the speakers.
Thank you, Fabio, for your presentation. And let me go directly to the agenda we have proposed for today. We are going to start with an introduction about what blockchain and what blockchain smart contracts solve for us. What are the main features and how does it works? We're going to see with a very simple example, what are the steps we need to follow to have a smart contract working for us? And also we are going to identify the advantage of having one of them working for us or for our business. Then we are going to see deeper into details about 5 scenarios in where the application of smart contract for FinTech will give advantage. Later on, we are going to describe a real problem we address with the blockchain chapter. We are going to go to details about the description, and then we're going to see how or the application we create, the proof of concept we create that we call MAAT, how it solves that problem. And of course, we are going to leave enough room at the end for question and answer. So let's get started. Every time we hear or we read about blockchain, the first thing that came to our mind is about cryptocurrency or Bitcoin. And that's true, it's okay, because it was the first implementation of blockchain. But blockchain is not only about crypto. It's a technology that is behind that came to solve some problems, like having information that we can rely on for companies or business process that not necessarily trust each other. Also, it helps in the trackability of assets. Think that there are some products that have dozens of steps in their supply chain journey. So every single record of those steps can be tracked and traded, and that evidence can be audited with security that cannot be undone or deleted. And when we talk about assets, we talk about things we can touch with our hands, like a house, a car, a piece of land, some products. And also it includes things we cannot touch that are intangible, like copyrights or even music. But the important thing here is that anything of value can be tracked using blockchain. Also, blockchain help us to prevent data corruption because the record of all the transactions are encrypted and immutable. And being immutable is one of the main features of blockchain. It means that we cannot modify, we cannot delete a transaction as it never happened. If we want to revert a transaction, we need to create the opposite transaction. But we are going to have track of both of them. Then also blockchains are distributed and decentralized. It means that all the network participants have a copy of the entire ledger, let's say of the entire database, for transparency. Also, there is no central authority that controls the network. Instead of that, there is a mechanism between the participants that is used to verify and validate transactions. That, in other words, it means that the network itself and the information that the network contains will be available even if some computers stop working due to hack or natural disaster. Also, another feature of blockchain is that it's secure because all the transactions are encrypted. And being encrypted adds another layer of security. And it means that only the enabled ones can read that information. What about smart contracts? What are they? How we can define them? Let's define in a simple word. Let's say a smart contract is a program that is stored on a blockchain that will execute immediately once predetermined conditions are met. Let's say it again. Computer program stored on a blockchain that will execute immediately once predetermined conditions are met. And they came to solve the problem of the execution of an agreement with minimum frictions, because there is no need of a third party involved. Also, smart contracts solve the problem of mutability of contracts, because once a smart contract is deployed on a blockchain, the smart contract agreement, let's say the terms and the conditions, cannot be altered. Even there are some mechanisms to update or to make them expire, the involved party should accept that to happen. And of course, smart contracts save time, because once the conditions are met, it will execute immediately with no time loss. Let's compare it, smart contract, with traditional contracts. The first thing we have to say about smart contract is that the terms and the conditions are written into line of code, and it will execute immediately once the conditions are met. While traditional contracts, terms and conditions are written into a document and requires manual enforcement to be executed. Let's see what are the steps we need to follow to have a smart contract working for us or for our business. The first thing we have to define is the business logic. That's one of the main important things. The involved party should identify and agree what they want, what is the desired output of the contract. Then they have to define and set the conditions that need to be met to the agreement to be executed. That part, the business logic, need to be clearly defined, because after this, the following steps are to write down that agreement into line of code, to create the smart contract, and once the smart contract is created, to encrypt and deploy on a blockchain. And once the smart contract is deployed on a blockchain, it will be there waiting for the conditions to be met to be executed. And once the conditions are met, it will automatically execute. And after the execution, all the network participants will receive an update about the result of that execution. Let's see with a very simple example how we can follow these steps. Imagine that Rodrigo lends me some money. Not too much money, but some money. So we define an agreement between us, and the agreement is that an interest charge will be applied if I pay late to Rodrigo, if I make a late payment. So after having defined the agreement, we set the conditions. If I pay before the 10th of the following month, there will be no interest charge. But if I pay later than the 10th of the following month, an interest charge will be applied. So that part is the business logic and is clearly defined. Let's see, on the step 3 and 4, that agreement will be written into lines of code. The terms and agreement will be converted into a smart contract and will be encrypted and deployed on a blockchain. Now we go to step 5. The smart contract is ready, waiting for the next payment to be executed. And let me say something here. I can pay back to Rodrigo with fiat money or some digital money. But if I pay with fiat money, there is a need to digitalize that payment to let the smart contract react to that. Saying that, imagine that I pay to Rodrigo later than the 10th of the following month. So the smart contract will react, will apply an interest charge, and it will update the next payment amount. And after that execution, on the last step, all the network participants will receive an update about the result of the execution of the smart contract. Once that are the entire flow to have a smart contract working for us. So let's identify here the advantage of having a smart contract between Rodrigo and I. First of all, Rodrigo cannot change the payment date, cannot change the payment amount. I can do it. Me neither. I can't do it. Then another advantage is that whenever required, we can check all the payments I made to Rodrigo. And there is another advantage, that there is no need of a third party involved. So there is no need of a middleman that can favor Rodrigo or can favor I. So that make it fair for both of us. Let's recap what are the main advantages of having a smart contract. First, we can speak about speed because they are executed immediately with no time loss. Then we talk about that there is no need of a third party involved. If we want, we can add a third party in the smart contract, but there is no need to have one to make the smart contract to work. All the transactions are encrypted to avoid security risk. And of course, we are going to have savings in time because they are executed immediately. And due to the fact of not having a third party involved, there are no fees to pay to a middleman there. The only fee we have to pay is for the use of the blockchain that are much less. So up to this point, we have seen what are the problems that blockchain and smart contract can solve. We have seen a very simple example about the steps to have a smart contract working for us. And now Rodrigo will continue with the presentation, going deeper into details about what are the benefits that applying a smart contract for fintech business can have. Thank you very much, and it's all yours, Rodrigo.
Okay, thank you, Pablo. Hi, everyone. Well, I am going to mention here about 5 use cases example for smart contracts applied for FinTech. The first one is related about trade solutions. Nowadays, international trades require a lot of paperwork, third party involved to do the verification about the contract. Also, the parties that is involved, we need to set the restriction about the content in order to interchange it, some assets, some goods related to that. Here, smart contracts came to solve with a digital solution that can be executed automatically and be on a blockchain network, and both parties can control what is going on during the execution on a smart contract, adding no restriction needed, and reduce the risk of tampering over there. So this is one of the first examples that we can apply smart contracts. The second one, as Pablo mentioned before, is related about lending. So we can customize a smart contract can be created for each type of loan. This is mean that let's have, for example, a set of tokens that we can divide representing a list of payment that we need to do. For example, I have 10 tokens that I can split it, and I have to set 10 payments to Pablo. If I delay with one of these payments, the smart contract will charge an interest for the delay date that I have not been accomplished from my side. So from the next payment, I will be charged with more interest in order to pay and accomplish the payment of this token. So the benefit that we have here, we can control the payment flow anytime, checking on the network transactions that are executed on the blockchain. We can audit them using the blockchain and calculate the proper interest rate in an automatically way. Then we have a third example here with KYC. KYC is basically know your customer process. As we can see, many software companies or entities, when we want to onboard another entity or another user, it takes a lot of time in order, and paperwork, of course, to validate the identity of the user, because sometimes requires a photo of the face, an ID identification that should be scanned, or some other extra information that is needed to validate that the user or the organization is basically real and trustable. So smart contract here comes to provide a digital solution that over the blockchain that is called related soul-bound tokens, which basically an NFT that cannot be transferable. And what's the goal here? This is the main goal that we have involved here is with this NFT that is not transferable, we can set all the attributes related to identify a digital ID or digital identification that can be traded between several organizations, guarantee and providing an easy onboard process with this information that already stored on the blockchain. With this, reduces the cost and time associated with the traditional know your customer process that we currently have. Then the next example is related about escrow. Escrow basically safeguard a payment while the deal between the parts is being done. A traditional escrow basically has two parties that not trust each other, so they put a third party in the middle in order to verify that the one of the party just do a deposit for the payment and other parties just send the asset or the goods needed for the other party to accomplish the deal. Here, now again, how we can do this with blockchain? Well, we can remove this third party, just put in a smart contract on the blockchain, and with this smart contract can be executed automatically, and this will be minimize the subjectivity because there will not be really a third party involved. It will be a computer program that will be here the third party, and of course we are going to save in time executing an escrow over here. Then,
Rodrigo, if I may interrupt you for a second, we have a question here from our audience. I think it's the right time to answer this. The question is, how do you manage on-chain and off-chain data? In the lending example, how will the smart contract execute the loan? Maybe you can answer our colleague here.
Okay. Well, one of the things that we can do is we can have off-chain data and on-chain data. The thing important here is for executing the smart contract will be the last step that we're doing for the loan. Here we just put, for example, on the central database that we just send an amount of money. We do a check and verifications, and when the check and verification is okay, we just execute the payment and the transaction over the smart contract in the blockchain. But this should be the last step that we do because this is basically a step over the blockchains or when you execute a transaction are basically immutable. That will be the basically functionality to execute a loan over a blockchain. One of the reasons that can be regulated here is, for example, you have a payment for an amount of money, and this amount of money can be represented with a list of tokens. So, for example, if you have $1 million, you can split it in tokens, for example, of 100,000. If in this case will be 10 tokens, and then with this you can add the interest per token over of the delay of time. So this will be charged, and then you can query the blockchain to verify all the transactions that were completed in amount of time. So you need to have all related to on-chain transaction, and you have all related about to off-chain that will be on your software platform. Is here basically the merge between Web 2 and Web 3, as we basically say. Here's another questions.
Maybe I think that this question is more general. We can leave it for the end. I would suggest that we continue, and this, as a general question, we can answer at the end of our presentation.
Okay. Well, after mention escrow, we're just going to our last case here, which is enforced compliance. Some market capital operations requires waiting time between buying and selling bonds for compliance. That can also apply for stock market and for example, securities transaction also. Having here a smart contract with these all restrictions that we needed in order to execute a capital market operation, will work automatically and instantly. And we can be used, for example, as a stock market to avoid the risk of non-compliance. The goal here of the smart contract is just to reduce this tedious process that some capital market operations currently have nowadays. So with this possibility, we enable the investor to focus on the opportunity instead of the constraint that we currently have. Okay. After mention these 5 use cases, we are going to onboard into a solution, basically an MVP that the intive team is working during this year in our chapter. We just created a software that basically is used to verify if certain amount of data was tampered over the time using a blockchain as a resources for verification. and we call this tool a master audit tool. In order to understand better this, which master audit, how master audit tool works, let's start first describing the problem. For example, there are some business process between parties that not trust each other, and there is a need for certain data between those parties. For example, audit report. Let's say we have two parties that need to interchange or verify audit report, and we just want to verify that the information provided was not tampered over the time in favor of one of the party. So how can we verify or check this in a proper way? Well, basically for that, here comes the master audit tool. Sorry, my camera was stopped. Can you still hear me?
Yes, carry on.
Yes, we can.
Okay, I don't know what I have a problem. Okay. Well, master audit tool receives sensitive data, stores the data in the database, calculate a unique identifier, and store on the blockchain. But what is the goal here? The goal here is related that the data that we are having currently stored will not be stored in the blockchain. Basically, we just only generate a unique identifier and store a unique identifier on the blockchain, which should be deployed on a transaction, and this should be immutable. The goal here is how we verify if the data not tampered or not. If we can generate the same unique identifier and compare it that the unique identifier is the same which was deployed or stored in blockchain on the blockchain, we just can say the data is basically equal and was not tampered over the time. If not, we can say the data was corrupted, changed, or modified. What is the benefits of that? Well, our sensitive data that have been provided for our software is just continuing to store on our database, so it will not public. But we have a unique identifier that when we store the data, we just generate the unique identifier, deploy on the blockchain, and then if we need to compare it, we can get this data without showing any public information. This combination of the advantages from database and blockchains gives certainty that data was not changed or modified without exposing sensitive data to the public. Now, as we can see, our master audit tool can have applied to another several examples. On this case, I'm just going to mention the insurance case. Let's say we have some precondition that we have some insurance company that actually provides to cars some IoT solutions, and these IoT solutions just basically sense car driving parameter when a car is basically moving, for example, the position of the car and the speed. So when there is an accident, those parameters should be reviewed in order to check and verify who basically was the accident cause. So again, let's recap again the problem. Insurance coverage is determined based on driving parameters, and liability, of course, is determined by these driving parameters too. How can be sure that those recorded driving parameters weren't changed in favor of one party and verify that one of the insurance company was not tampered the data? With the master audit tool comes again here. Basically, master audit tool will receive the app for the parameter, we store on the database, and then we just calculate the unique identifier and store on the blockchain. When the accident happens, we just gather all this recorded data over the time with all this unique identifier provided, and we just can compare basically if the data was stored was tampered or not. In this case, we have an example. If the data matches and was not tampered over time, we solve all these driving parameters about the vehicle, and this case is not. We just not show anything related to that. Well, there are other several cases that we can apply our master audit tool, but we are running out of scope and time.
but we can discuss this on the future. Now we are just going to open a Q&A session with you guys in order to send up some questions about this webinar.
Okay, thanks, Rodrigo. First of all, before we go to questions, as you know, we love to give some work to our audience. I will share with you a poll that will be interesting for us to know what's your area of application, or where do you see that smart contracts can be applied in your line of business. As while you are filling the poll, I will reply the question that we have from one of our audience members. And the questions would be, what are the main limitations of using blockchain transactions for smart contracts? Some examples could be processing speed, transaction cost, limitation on quantity or request per time, system throughput, etc. Maybe you can elaborate on that, Rodrigo.
Okay, this always depends on the network that you choose first. Because there are networks, for example, that's Bitcoin or Ethereum, that takes more fee in order to introduce a transaction. Of course, network nowadays is the most popular blockchain network in order to send transaction and execute it. But it's especially used right to this is for DeFi and investment. But then you can use another blockchains like Polygon that is Ethereum-like, that, or some AVAX that can be Ethereum-like and deploy, for example, some Solidity code over there, and the fee cost will be lower and the transaction speed will be executed automatically. If you want to have a real speed blockchain that you want to execute, but the smart contract over there are kindly more complex, you can use Solana, for example, that can process a block per half second and can provide, for example, a list or 5,000 transactions at least, or more in other cases. Then we have another question here. Is possible to apply on, yes, there are several cases that you can apply on the oil field industry. We have several case that we have to tokenize petrol barrels in order to, you can use it as a fungible token per petrol barrel, and you can create a tokenized system and your tokenized economics for this if you want. So yes, yes can be applied. If you are interested, you can contact us and we can set a meeting about this.
Yeah, also, let me add something there, that there are sometimes drilling parameters that we are not sure if they are true or not. So using blockchain, it solves the problem of certain, that you are completely sure that those drilling parameters are true. You have certain that they are drilling that you are seeing and they are not lying on that. For example, also about what Rodrigo said about the trackability, you can track all the steps of some oil fields till they are ready to sell as a derivative product.
We have another question, and is the following. Could you please elaborate on how do we connect real-world data with data on the blockchain? How do we feed the information to the smart contract to act on?
Well, this question is depend over the domain. But basically, let's say that, for example, you can represent, as we mentioned, for example, for the loan example again, an amount of fiat money that can be represented with a token, okay, over an amount of token. So we can get this real data, transform it into a token or represent it into a token and deploy it on a blockchain. So this is here, again, the limits between Web 2 or reality, as you can say it if you want it, and the Web 3, which is all related to the blockchain. How do you can the smart contract act on? Well, the smart contract will start consuming this set of fungible token in the case for a loan. And with this, you can, when the old token starts consuming, you can verify, okay, the contract has accomplished it. So I think the loan that I have with Pablo is also accomplished too. And this, for example, we just can burn the token or close this basically a smart contract to not continue executing over the time. That can be one of the reasons. But I mean, it's always depend on the domain that you need to working on. Because, for example, let's say another example. If I want to have a digital identity, I need to translate it into non-transferable NFT. So because my ID should be unique and should not be transferable. So it's always the pain of the domain of the solution that you want to cover. Is there are many uses that we currently have. So for an example, if I have a piece of art and I just want to sell it, I just want to sell it as an NFT, for example. That is token that can be transferable. And for example, if my piece of art is selling over the time, I can get royalties, and the royalties can be deployed over the smart contract. I can have royalty related to a certain amount of token, and then of course using an exchange or a service to convert these tokens into fiat money. I don't know if there's another question.
There is another one, Rodrigo, that says, given this advantage, what is stopping it from being more used in day-to-day business?
Given this advantage, what is stopping it from being more used? The advantage for a smart contract, what is can generate the stopping for uses? Well, it's basically we need to have first people that are expert on Web3 development, and then trying to find or match the better. For example, in the case that you want to use token, you want to use a network, you need to verify which are the best technical requirement that match with your solution over the day. So what is stopping is basically you need to research, investigate what is the better proper solution that accomplish to your project, and then, for example, have an engineering team that can be applied that solution. So there's no practically technical limitations to execute a blockchain solution over there with a smart contract. The thing is just to find the proper domain and the proper, in the case, for example, for Ethereum, proper ERC specification that matches with your solution. Then,
if I may add a little bit on top of that, I would say that like any transformative technology, it takes some time until it gains acceptance that the new processes will present advantages over the present ones. In some cases, you would need some regulatory adjustments, and in some others, it's a matter of industry adoption. Currently, what we are trying to do is, having seen a number of the advantages that we can elaborate on that over the next question, we are trying to link with different industry actors and see how we can introduce those advantages in the real world, in the domains where we are acting. But essentially, it's like any other transformative technology. It takes some time and some good examples until it gets broadly adopted by the industry. Maybe we can go to again and review what the advantages of the smart contracts are, Rodrigo.
Okay. Pablo, can you go to the slide for smart contract advantages?
Yes, sure.
Do a recap over there.
Yes. Sorry, let's present again.
One of the advantages for smart contracts is you can do automated solution over there. And automatization is one of the first advantages that can be done. The other thing, you have the blockchain. The blockchain basically can track all the movements are executed over the transaction that you have over your smart contracts. And basically all the movements for transaction that basically are executed are immutable. So the other is the speed and efficiency. If you have, for example, a blockchain like Algorand or Solana,
you can execute a lot of transactions and having multiple smart contract solutions providing over your time. And that can be executing, like, for example, a Solana block can execute about 5K transaction in 5 seconds. So it's like a good volume of transaction that can be consumed over a certain amount of time. And you can have a smart contract deployed over there and execute all the instruction that is needed. The other thing is the security. This information is basically encrypted. So you can reduce all security risks. And this, you have trust and transparency. You have no third party involved. many human process that can be done using an automatically using a third party can be basically automated by a smart contract nowadays. So I don't know if you have any other question about this.
I can add something there, Rodrigo, about the third party involved. There is no need of having a third party to make a smart contract work. But in case of needed, smart contract can act as a third party. So using a smart contract, you avoid the risk of subjectivity. In the example you said about an escrow, once some milestones are reached and the payment needs to be sent to someone, you avoid having subjectivity on that. You just have some condition that if they are met, you are going to get paid. And there is no a single person that controls that.
Okay, I think there's no more question for now.
So I will give some time frame if there's any other question from our audience. Okay. Seems that for now there's no questions. Obviously, this does
There's
not
another
end.
one.
This another one?
Another one, yeah.
But it's,
Yeah, okay, good.
It's the same.
Yeah.
Where's the main limitation?
What are the main limitations of using blockchain transactions for smart contracts? Yeah, I believe we answered already that. This
Yes.
is a repeated question. What are the main limitations? Maybe we can shortly review that in order to make sure that we left no question unanswered. Just to mention the limitations that we might face.
Okay. One of the limitation that you can have, for example, is a transaction over a blockchain basically cannot be undone. You can revert the transaction, which is okay because let's say we have an address A, just send some funds to an address B. There will be deploying on a layer, and this will be immutable. But you can revert, of course, the transaction, sending the same funds again. You will have the 2 fee costs that we should pay over this time. So the blockchain basically you can see it has a limitation and has a feature over the time. But for example, if you can use the blockchain over a core banking, maybe it could be another better option to do if you want to remove some transaction over the time. So that could be, for example, one of limitation. It of course depends on the domain and the use cases that you can apply. The other things is, for example, you need to check if your blockchain solution cannot be applied via Web 2 instead of Web 3, because some blockchain solutions are not needed and can be solved using just only your database and something that you need not to be applied over the Web 3 with no transaction and selecting a blockchain. So it's always, I think, depends on the domain. That's I just consider you need to analyze each use case to say, okay, which limitation have here.
Yeah, Rodrigo, and the same question, it talks about transaction cost and limitation on quantity of requests per time.
Transaction cost depends always on the network that you are executing. Again, for example, if you use BTC, your fee will be higher. If you execute on Ethereum, your fee will be higher. If, for example, if you Tron and you can deploy, for example, USDT or Samsung USDT, fee are lower. So always depend on the chain that are deploying your smart contract. Are all. And then the other question is what related the limitation
of quantity. Yeah.
The quantity of requests are processed per block. So if your transaction basically is not processing in the block, for example, number 1, the transaction should be sent by the node, dispersed over the node, analyze it, and verify that signatures are okay and everything is okay, and we'll deploy it over the block. If you want to have a blockchain that has more throughput, you need to check over the blockchain specification, which supports a more transaction that can be processing over time. In this case, of course, again, I will recommend Solana for doing that. That basically process per second 2 blocks, and I think 500,000 transactions. That could be the throughput or less, but it's really high speed blockchain in order to do that. The only difficult for Solana is develop the smart contract for this blockchain because are not support yet Solidity. There's just one try to move to pseudo Solidity solution, but it's not covered yet.
Okay.
That's what's my last answer.
Yeah, I think that we have answered the question. Okay, let me check once more. Yeah.
Okay.
Which blockchain platform supports smart contracts? Which are the best in your view?
Okay. Yeah. Well, basically, all blockchains that support a smart contract are just basically that. This is a more technical concept that can support a Turing complete language. Okay. If you support a Turing.
Okay, I think that Rodrigo got interrupted. What he was about to say is that if a given chain supports a Turing complete language, is a condition to support smart contract. There are a number of chains that satisfy this condition. Okay.
Was chopped the transmission.
Yeah, I think that I just completed the phrase related to Turing complete. I guess we can answer this question if you want, and I think we're there.
Okay. Basically, which are the best in your view? Well, I will consider 3 for now that I like it. One is related Solana, which is really high speed and supports a lot of tokens. You can create a lot of tokens. You can create a lot of receipt address. Is really manageable. The only difficulty here is develop and deploy a smart contract. If you want to go more easy and you have more information, I will recommend to use Polygon or some AVAX related to deploy a smart contract, which AVAX is related AVAX for Ethereum, Avalanche for Ethereum, that you can support an EVM here and you can deploy over there Solidity code, because nowadays Solidity code is the most popular language to deploy a smart contract. You have a lot of examples to do. So I will consider Polygon, some related to AVAX. You can use Ethereum if you want, but the cost of the fee will be more charged. So I will not recommend Ethereum to use in this case. If you want to be sure, if you want to ensure that your transactions are going to be okay, if you want to accomplish some extra requirement that your client need or you want to develop, well, you can use Ethereum if you want.
So I guess with that we have answered our last question. Sure. And I think we are almost done with the time. So let me please thank you in first place our speakers today and also our audience to have shared with us this piece of knowledge. Please remember that this is not the end of smart contracts and blockchain, but just the start of a dialogue. You can follow us on LinkedIn and get in touch with us at any moment, and we can discuss in depth the particular need for your business and how can this technology help the processes that you are currently executing. Thanks, goodbye, and have a nice day. Thank you very much.
Yep.